Welcome back. This is the day the Lord's made. Let us rejoice and be glad in it. In this video, I'm going to talk about dielectric constants and capacitors for circuitry. So a capacitor is basically the idea that we can have some energy just stored in a circuit. It's like a temporary battery. However, the general idea is as electrons, so we have a broken circuit here. So looking at the screen here, we have a broken circuit, and there's this gap between it. A capacitor is this idea that between here and there, between the two different plates, we have some potential, some stored energy. And as the charge builds up, what's going to happen is every now and then it'll zap across. So you can think of like this also being like a signaling thing. So for capacitors, they often can signal something in the circuit. So that way, it's not continuous current. It's as the electrons build up, zaps across, zaps across. This is the general idea. So this is important for things like some applications, windshield wipers. The way windshield wipers is you would just, when you would change how fast it goes, all you're doing is really changing the distance between different plates. And so if you get them closer together or farther apart, it changes how long it takes for it to zap across. When you get them closer, it's going to zap faster. And you pull them apart, it'll zap slower. And so really when you're just changing a little dial, you can think of it like, oh, I'm just changing how far apart these metal plates are. So as the current goes through, every time it zaps across, it signals, hey, windshield wiper should go. All right, so if you want it to go less often, you just pull it apart, and then it zaps less often because it takes a bigger charge to build up. Another example of capacitors would be an AED. Basically, what's going to happen is it says charging. What's happening is they have two different plates, one positive, one negative, and they're making both of them really positive, negative, and then when they're ready, they're like, okay, now put it on there. And so that's all really what capacitor is. It's like a temporary battery with a temporary charge. So anyway, you should think about capacitors being just a temporary battery, a storage of energy. Now, the amount of energy that is stored depends on a couple things. It depends on how close the plates are. So if the plates get closer together, the energy that can be stored between them gets larger because of the electric field getting larger as well. If the plates get bigger too, there's more energy. So if the surface area of the plates gets larger, you get a bigger capacitor. If it gets smaller, you have a smaller capacitor. If the plates get further apart, you have less energy. If the plates get closer together, there's more energy. Now again, why is this? Why is there more energy when they're closer together? It comes down to the voltage lines that are being generated. So the farther apart these plates are, the positive and negatives, farther apart these are, the weaker the field is between them. The voltage between these things is lessening. As they get closer and closer and closer, the voltages will increase because the field lines are going to be stacked closer together. So one more thing to mention too, that's really important for one more thing that's really important for capacitors is the idea that dielectric. Dielectric constants are basically think of like how resistive is the material towards electrons moving through it. All right, so in a capacitor, you can change what's between it. Like, so here we have just nothing, it's just air. And when I say nothing, air. All right, air is defined as a dielectric of 1, meaning that was just the default. So if you're more resistive than air, then your dielectric constant is bigger than 1. If you're less resistive than air, then you're going to be less than 1. So again, if this was like, if we just put a piece of metal between here, we could think of that dielectric constant being very tiny. There's like being, no temporary storage because electrons just move from top to bottom or bottom to top. There's no stopping. And so when you put something between it that's insulative, this results in the charges that are being built up getting larger. Why? Because what's going to happen is as the voltages or as the electrons congregate onto one side, they're going to zap across and they're never going to keep building up because once they get to a certain threshold, it zaps across. So electron comes, we've reached our threshold, zaps across. By putting something resistive between it, this makes it harder for the electrons to zap across. So when you do that, that actually increases the amount of energy that can be stored. And so you can also think of this too, like a way that you could build a capacitor to release energy is you put something between it that's resistive, then you pull it out. And when you pull it out, all the excess charge that built up here zaps across real quick. So that's another way to think of it as well. But as far as you're concerned, the dielectric constant is just basically the idea of like, how hard is it for electrons to zap through this material? How good of it is an insulator? So metals have a very small number, plastics have a very large value. So So when you connect the dielectric constant to the energy stored, you should associate a large dielectric constant with a lot of energy stored. So if we have a big dielectric constant, we're going to be able to build up a big excess charge on both sides. We're going to have a big voltage being generated, and then we have more energy being stored there. So again, we can look at this. We got some nice little graphs you can bring in here. So when we bring in our dielectric, we're going to see that the plate, the charge is going to increase, and the energy stored increases as well. So before, we can only build up a certain charge before it zaps across. Adding our dielectric, now we can build up more charge before it jumps across. And because we can build up more charge, we have more stored energy. So that's why also too with AEDs, there's like child or adult based on the amount of energy they want to give through the shock. So capacitance and energy aren't exactly the same thing, but as far as we're concerned, they are proportional to each other. All right. I think that about summarizes capacitors and dielectrics for this class. We're not going to be doing any circuitry with them, but I'm sure in your next physics class, or if you get into any higher level circuitry stuff, these would be really important stuff for you. Godspeed.